All right. So in our lecture one, we were talking about forces, and under forces, we came across a sub-topic known as Newton's law of motion. We learned the other day plenty about Newton's first law of motion, okay, where we said it states that everybody continue to stay at rest, or it's moving, continue to move in straight line with uniform velocity unless it is acted upon by an unbalanced force to change its state. Okay, if I say its state, that is, it means that it could either be the state of rest or the state of what? Motion. Okay, and the other day I gave you some practical scenarios. Okay, so to be able to know whether you really revised your notes or not, I want to just throw a practical question. If you're able to answer, it means that you really understood all the concept of Newton's first law of motion. I remember we also said Newton's first law of motion is also known as what? The law of inertia. Okay, so I want to just pose a question to you. Okay, yes. Let's say
Okay.
you and your family, you are going to um church, okay, early Sunday morning, and then in the course of driving, your daddy accidentally stepped on the brake paddle because a goat crossed the car, okay, or the goat crossed the road. So due to that, um, Believe was complaining that your daddy has made his head to hit uh, the chair. Okay, so as a physicist in the car with your family going to church, how will you be able to resolve this issue with the idea of Newton's law of motion once you have been taught?
Fair enough. The fourth.
Yes, I'm listening. Hello. How,
Hi.
as a physicist in the car at that moment, how will you be able to resolve the issue to explain to belief with Newton's law of motion, whether it is your daddy that caused uh, uh, his head to hit the chair or it is not. Okay, so explain with Newton's law of motion the phenomenon and validate whether your daddy was the cause or not.
I'll tell him that because the car was moving with a constant velocity, and all of a sudden, because the goods came to cross, he has to stop, like has to stop so that you won't hit the goods. So when the car was moving with a constant velocity, when it stopped, it will come at rest, so to it will this one. It will so when the thing comes at rest, it becomes zero. So that's why his head hits the chair.
Oh, okay, you have tried. If I'm supposed to score you, I'll give you 4/10 for just omitting a word. Yes, and that is belief's body assumed the initial velocity of the hot car. Okay, let's say if the car was moving with a velocity of 10 meters per second squared, and your daddy accidentally stepped on the brake paddle, it means that the final velocity of the car has what? Reduced. But Belief's body still assumed the initial velocity of the car, which was what? 10 meters per second squared. That is why his head what? Hit the chair. So, in short, it is the force of inertia that led to his head hitting the chair, and it is not your daddy's what? Fault. Okay,
Okay.
that is why it is always recommended of us to what? Use seat belts when we are seated in cars. I hope you now understand the whole concept. Yes.
Yes.
So when we still went on to say that if a force act on a body that is it, a body that is moving or a body that it has rest, at the end of the day, you realize that it may cause a body that it has rest to move, or it may also cause a body in motion to increase its motion, okay, to increase its motion or reduce what? Its motion. Also, it may also cause a change in direction, okay? It may also cause a change in direction, and also it may cause a change in shape. A change in shape in some cases when you see change in dimension is the same thing. Change in shape is the same as what? Change in dimension. Good students should have notes and jotter, pen and paper beside them, so that when the lecturer or a teacher make a vital point, he or she will be able to what? Write some of these things. And these are some of the things that make you a very, very good student. Okay. Because you have to have reference material, and that is your literature review. All right. So we went on and we discussed, and that is that scenario, the scenario I just gave you. This is the scenario over here. Okay. Listen. Okay. Kindly read the scenario out and let's all hear.
This is an object that an object at rest begins to move only when it is pushed or pulled. That is when a force acts on it. Passengers in a bus or car are jerked forward when the car suddenly stops. The parts of the body which are not in constant with the chair continue in their state of motion until brought to rest by friction or collision. The purpose of the seat belt is to prevent the passengers who wears it from being thrown forward or injured during a frontal impact.
All right. All right. All right. So you have to kindly continue to the end. So now you have seen the reason why they said that what the purpose of seat belt is to prevent the passenger who wears it from being thrown forward and injured during a hot frontal hot impact. So that is the main reason why, underline this in your notebook. Okay, this is the main reason why seat belts are provided in a car. Okay, so you can see that the cause of Belief's head hitting the chair is because he didn't wear seat belt. If he had wear the seat belt would have what? Absorbed his kinetic energy. I hope you are you are receiving the message I'm trying to put across. So we
Yes,
are
please.
saying that inertia depends on what? Mass. Okay. If let's say you move forward or you remain at rest, inertia, your turn. If I hit you now, as to whether you move forward or not, it depends on your mass. Let's say right now, if you have a mass of 60 kg, okay, do you think a 5 years old boy can be able to raise you? No, because you are at rest.
So,
He can never raise you. Okay. But if let's say maybe a 35-year-old man and you who is 60 kg, you are at rest, he can come and raise you. So you can see that the force of inertia actually depends on the mass of the body. You see. So the first concept you're supposed to know is that inertia, which is Newton's first law of motion, okay, depends on what? Mass. So if they say mass, that's what they are trying to explain to you in this concept. And they are saying that what? The larger the mass of the body, the higher its inertial what? Property. Okay. The higher the mass of the body, the higher its inertial property. Newton's first law and the concept of inertia are identical. Hence, the law is sometimes called the law of inertia. So we went on to discuss momentum of a body is the product of mass and velocity when it is in what? Motion. And what does that imply? That implies that a body at what? Rest has no momentum, true or false.
true.
And why is that so? Can you explain to me why that is so? Can you
Why
explain
what is to?
mathematically? Can you explain to me why a body at rest has no momentum?
What
Mathematically,
is to?
can you explain to me why a body at rest has no momentum? Okay, let me explain to you, and I'm sure after today you'll be able to remember forever and ever. You see, we say a momentum is equal to the what? The product, the momentum of a body is the product of its mass and velocity when it is in motion. When it is in motion, it's a key point. You don't have to throw it away in your definition. When it is in motion does not come, whatever you have written is wrong because we don't know whether the body is at rest or not. So we are saying that it is a product of what? Its mass and velocity. So this implies that momentum, okay, is equal to what? the mass, okay, times what? Velocity.
Yes.
Do you understand me? Of a body in
Yes.
motion. You said I have put direction on it.
Yes.
So in this case, if the this is when the body is in motion. So this is when if the body is in motion. So you can see me writing motion over here. Okay, good. Come and look at a different scenario. If the body is at rest, let's say if the body is at rest, then it means that our momentum is going to be equal to what? A body that is at rest has mass. You understand me?
Yes.
So we can write mass. Now, if your velocity, you are at rest, you are not moving. What is the value of your velocity? It is what?
Yes.
It is zero. A body at rest has a velocity of zero. Its initial velocity is still zero. Okay. So at the end of the day, you see that what? Your momentum is going to be equal to what? Any number times zero is equal to what?
No.
Zero. So that is why we are saying that a body at rest has what? No momentum. You see. Over here, you see that
Mm.
even this one, this meters have written, this mass have written over here, it has a coefficient of 1. Do you believe that?
Yes.
And the velocity over here too, it has a coefficient of what? 1.
One.
Uh-huh. But in this case, this guy, it has a 0 hot initial hot velocity. So
Yes.
it is invalid. Do you understand me? Uh-huh.
Yes.
All right. All right. All right. So let's continue. So, so that is what they are trying to express over where they are saying momentum is equal to mass times what? Velocity. In some cases, you just see momentum and it's equal to what? Mv. Don't get confused by that. All right. The SI unit of momentum is what? Kilogram meters per seconds or newtons.
Yes.
Newton seconds, okay, or newtons
Yes.
seconds. Also, momentum is a vector quantity. Why are we saying momentum is a vector quantity? It's a vector quantity because of what? Uh, because of the velocity. Okay. I told you that velocity is not distance over time. Velocity is actually what? Displacement. If I say displacement, displacement is different from distance. Okay. Because displacement is a distance with direction. You understand me? So that is bringing about the arrow over here. So this momentum of a body at rest I have denoted over here. You can see that this guy over here, it has no arrow on top. Because if you are at rest, you are not moving. Which direction are you heading to? Okay, so that is why we are saying it is invalid. On this case, I still stand to stamp and say that the laws of physics are the same for what? Observers in relative motion to what? One another. Yes, the laws of physics are the same for all observers in relative motion. Okay, yeah, so no matter how you apply them, if they are really speaking the truth mathematically truth should also validate it. And that is what we term as a scientific or a valid scientific research. But suppose a body of mass, kg, increases its speed from initial velocity to what final velocity in time interval what of what this. Okay, its initial momentum can be of the body can be written as what? Mu. You see, mass times what? The initial velocity. And the final velocity can also be denoted as what? Mv. Okay. But you realize that at this case, the change in momentum of the body, if you want to write it finally, what is it going to be? It's just going to be Mv minus what?
Yes.
Mu.
Yes.
So you understand where this concept is coming from.
Yes.
So if I say you should write the final momentum of a body, how are you going to write it? Final momentum of a body, how is it going to look like?
M to bracket V minus 2.
Come again.
M to bracket V minus 2.
No, I want you to write the final momentum. Final momentum. The final momentum is equal to what? Mv. Don't get
Okay.
confused. You see? And the initial momentum, what is initial momentum going to be?
MV minus 10.
No, I'm coming. The initial momentum, get a difference. What is the initial momentum going to be? You just saw it. The initial momentum is going to be mu. You see. So come and see it over here. That is what is over here you are seeing now. So they are saying that
Yes.
initial momentum of the body is what? Mu. You see, that is mass times the
Yes.
initial velocity. And then
Yes.
the final momentum is also denoted as what? Mass
Final
times
momentum.
velocity. You see, and that is the mv. Okay, I'll ask you one day again, and I expect you to be able to tell me. But if they say change in momentum, then it means that the change in momentum itself is equal to what? Mv minus what?
Yes.
Mu.
Anyway,
You see, so at the end of the day, by substitution, you can substitute the m out, and you are going to have what? V minus what? U.
yes. You.
You see, V
Yes.
minus U is common. You have seen it before, right?
Right. Right.
Final velocity minus initial velocity. You have seen it somewhere. That is change in what?
Yes.
That is change in what? Velocity. Okay.
Yes.
So momentum is just can also be explained as what? The product of mass times what? Change in velocity of a what? A body. Okay. Yes.
Okay.
So let's quickly look at if you divide this by time. At the end of the day, if you divide this by time, then you realize that you are going to get what? Your m. But we are going to meet that in let's say Newton's second law of motion. So let me leave it over here. Now let's continue with the Newton's second law of motion. Kindly read and let's continue.
18-second law of motion. 18-second law of motion
But
states that
I'm coming. Before you continue, do you have any question to ask on Newton's first law of motion? Any scenario? Do you have any question to ask for me? Any practical question?
mm, no, no.
All right. So you can proceed from Newton's second law of motion.
18-second law of motion. Newton's second law of motion states that the time rate of change of momentum of an object is directly proportional to the force acting on it and takes place in the direct of the force. For example, a, la a large force is required to stop the motion of a body in a short time, and small force will stop the motion in a longer time. Mathematically, the second law can be expressed as force equals change in momentum over time taken for the change. F equals mv minus mu over time. Relationship between force, mass, and acceleration.
Okay. It's okay. So the one you just explained to me now, that is Newton's second law of motion. And what are you just trying? You are trying to tell me that uh, Newton's second law of motion states that the time rate of change in momentum is directly proportional to the applied force and takes place in the direction of the force. I hope now you can be able to state some of these laws on your own.
Yes.
Which, be sincere, which of the laws, how many, the three laws, how many do you think you can be able to state on your own so far?
Three. All of them.
You can state all the three if I close the book. No.
Yes.
Are you sure? Okay, so
Yes.
when I meet you in person, I'll close the book and ask you to state Newton's first law of motion. That is the longest
Okay.
one, and see if you'll be able to state it. If you're able to state it, congratulations, well done. You see, your friend was able to state it, so you also have to know how to be able to state it, so that if you go somewhere and they are saying something, you also be able to say some. Other than that, you always be quiet. Okay. So I want to just give you a practical question on Newton's first law of motion, even before we come to the Newton's second law of motion. Okay. So listen,
Okay.
uh, a ball rolling on a smooth surface. Let's say a ball rolling on smooth surface keeps moving at 2 meters per second. What force is required to keep it moving at that speed?
Please come again.
I'm saying that
Hmm.
we are still on, let me say that we are still on the first law. So I just want to give you a practical question. Since you said You don't have any question for me. I want to give you a practical question before we come and proceed with Newton's second law of motion. Is that clear?
Okay.
So I'm saying that, let's assume that air is blowing, okay, and all of a sudden, a ball started rolling on what? In your in on your compound, okay? A ball, I can see a football in your house. So let's say that football, air is blowing, all of a sudden the ball started moving at let's say a velocity of 2 meters per second. So what force is required to what? Keep it moving at that speed?
Oh, that time the ball was this one at rest.
No, let's just say the ball was moving. When let's say you were inside the room, okay, so when you just opened the door, you saw that the ball was moving with let's say a velocity of 2 meters per second. Okay. Uh-huh. So if I say the velocity of 2 meters per second, don't get confused. So it's just the distance, okay, divided by the time. And what do you think the distance is going to be in this case?
This time,
The distance could be 4 and the time could be 2. You see? In this case, let's not even use distance because the thing is the ball is moving in a specific direction. So we say the displacement is what? 4 meters. And then the time interval is what? 2 seconds. So at the end of the day, if you divide it, you get what? At the end of the day, when you divide it, that is when we get a 2 meters per what? Per seconds. So I'm asking you that let's say the ball is moving with 2 meters per second. What force is required to keep it moving?
the ball will cry.
Yes, to keep the ball moving at that speed. At the speed of what?
Am I supposed to solve it or
No, it's just a practical question I'm asking you. You are not supposed to solve this. Okay, you let me help you out.
what?
It implies that no force is required. Okay, if you ignore friction, according to Newton's law, it will continue moving until it is acted upon by an external what? Force.
Yes.
Do you understand me? And that force will be what? Wind, maybe some cat will come and hit it, or it will go and hit something by itself and stop. Do you understand me? So
Yes.
ideally, that ball that you came out of your room and you saw that it was moving, it would have continued moving with the uniform velocity of 2 meters per second, okay, around the compound until it is acted upon by what? A force. Do you understand me?
Yes.
Okay.
Yes.
So that is all what Newton's law of motion is also. First law of motion is trying to tell us. Okay. The second law of motion, for example, a larger force is required to stop the motion of a body in short time, and small force will stop the motion in a longer time. How do you understand this statement? That is, listen, if let's say a car is moving with what? A velocity of what? 50
Is
meters.
it like a car?
Eh?
You say a car.
Listen to my example. After reading the Newton's second of law of motion, what did you say Newton's second law of motion is? This one, you told me that Newton's second law of motion states that the time rate of change of momentum of an object is directly proportional to the force acting on it and takes place in the direction of the hot force. Okay. So if you are moving in the east and I come and hit you towards the north, it means that your direction will change and you'll be moving towards the north. Okay. That is what Newton's second law of motion is trying to say. You. So mathematically, or for example, we took this example. Okay. And the example, I'm saying that a larger force is required to stop the motion of a body in a short time, and small force will stop the motion in longer time. How do you understand that? How do you understand that as a physicist? It is as simple as that. Okay, if a car is moving with a velocity of 50 meters, okay, let's say the car is moving with a velocity of 50 meters per second, and you want this car to stop faster, what do you think you have to do? You have to use larger force. Okay, and that is what they mean by what? A larger force is required to stop the what? motion
Motion
of the
of
body
body.
in a short time. Okay. So if you don't apply a larger force, the body will keep moving. Okay. But if let's say the force is small, it means that it will take time before the body will what? Stop. Do you understand?
Hmm.
Do you understand the whole scenario I'm trying to put across? Let me give you a different scenario. Let's say that um,
Hmm.
um, let's say all of a sudden you are going somewhere, or in the course of going to the church in the car, all of a sudden your car broke down. Okay. And then because it's Sunday, no one is willing to help. So our Boboya driver came to what? Uh, help uh, you people. Okay. Or let's say that um, in the course of you going, or
Hmm.
let's say in the course of you going, you accidentally failed your brake. Okay. So in the course of you failing your brake, we are supposed to find a way to stop your car from what? Moving. Okay.
Hmm.
So if we want to stop your car from moving, if it's Sunday, we don't have much cars on the way, and we want to use a aboboya, we hook rope on the aboboya and hook it to your car to try to stop it, as compared to let's say a tipper truck. Who do you think will stop the car faster?
Hmm.
Hello,
Hi.
I'm saying that aboboya,
Hmm.
the car, and a tipper car stopping the car. Who do you think will stop the car faster?
It's pa. Ah.
The tipper car.
Yes.
Because you see that the tipper car, it has a what? A larger force. You see,
Yes.
the tipper car, it has a larger force, but the aboboya, no, it doesn't have a larger. It may stop the car from moving, no, but it may take time. You understand me?
Yes.
It may take time. It may take time. An example is, let's say uh, you are climbing a slope. Okay, all of a
Oh.
sudden your car broke down. Okay. But when the car broke down,
Hmm.
you realize that the car what kept moving. It kept moving. Oh, it is still moving small, 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 small. Before you realize it will fall in the water over here. So now you have to what? Use a boboya to tie it and pull it out of the what? The slope. So
Hmm.
a boboya pulling this car out and a tipper car pulling this car out. Who do you think will pull it out faster? It is the
It's
tipper.
Parker.
Yes, that will be able to pull your car that is moving into the water faster than the what? Aboboya. So that is all what the Newton's second law is. Law of motion is trying to what? Put across to us. Okay. So I've taken my time to break this section. In 10 minutes time, the link is going to go up. You have to re-click it to be able to enjoy more. All right. All right. So we are saying that mathematically, the second law can be expressed as our force,
Yes.
okay, being directly proportional to what? Change in momentum
Thank
over the
you very
time
much.
taken. So you see, change in momentum over
Yes.
the time taken. In Newton's first law of motion, what did we learn? In Newton's first law of motion, what did we learn? We learned that our force is equal to what?
Yes.
Our change in momentum of a body is equal to what? The change in momentum of a body is equal to what?
V minus MU.
Yes, we learned that our change in momentum is equal to, let's say,
M.
force times what? Change in velocity. Let mass times change in what? Velocity. I can also
Yes.
put it that way. Okay. Yes, our momentum Z is equal to mass times the change in velocity. So if momentum is equal to mass times change in velocity, what does that imply? It implies that in the Newton's second law of motion, they just divide this by what? Time. Then they just divide the whole of this by time. That is all. So it is easy to remember. If you multiply this back again, you get the expression they are also getting over here. Okay, just that we have got the m outside of the bracket. Yes. So they are saying that the force is directly proportional to change in momentum all over time taken for the change. Yes. So mathematically, this was written theoretically. Okay, this over here is theoretically. This is theory. But you realize that mathematically, this was further explained what? Better. So mathematically, what can you see? You can see your
You see,
force being directly proportional to what? Mv minus mu all over the time taken, right?
yes,
Okay.
yes.
If they say something is proportional, what does that mean? When we say something is
As,
proportional, what does that mean?
like as this one is moving towards the right, the other one too is moving the same direction.
Okay. All right. You have tried. So the relationship between force, mass, and acceleration, we want to look at the relationship between what? Force, mass, and acceleration. I believe you have heard of, let's say, um, force. You have heard of force, right?
Yes,
You have also heard of mass, and
yes,
you have also heard of acceleration.
yes,
Okay, so we want to know the relationship between them. We want to know whether they are brothers, cousins, nephews. We want to know more. We are curious. Okay, so due to that,
yes.
we are going to find a way to establish a formula that we can use to make life easier. So these are the relationships, and you realize that from Newton's second law of motion, we had this formula where we are saying that what uh, the rate of change in momentum of a body is directly proportional to the applied force and takes place in the direction of the force. That is all this law is trying to say. At the end of the day, if you want to get rid of the proportional sign, what are you going to put over there? You have to bring equal to, but after bringing the equal to, you have to introduce a k. You understand why the k came?
Yes.
Yes. So still all conditions are the same. But you can see that v minus u over t is equal to what? A. So at the end of the day, you can say that the whole of Newton's second law of motion is equal to what?
Equals
F is equal to
K
what?
times.
Ma. Okay. Force is equal to the constant times the what? Mass times acceleration. All right. So let's look at this page. And in this page, you are realizing that from system, okay, let me put asterisk over here. From system of unit, the Newton is defined as the force needed to give a mass of 1 kg and acceleration of what? 1 meters per second. This implies that k is equal to what?
1.
So that k is equal to 1. So if k is equal to 1, finally, what are we getting as our formula? Finally, we are seeing that our force is equal to what?
Mass times acceleration.
Mass times acceleration. I can tell you to come and prove the formula. Force is equal to what? Mass times what? Acceleration. From Newton's second law of motion, you should be able to do that. If you look into your past question, it is an examination question. It has been asked before. Okay. So you have to
Right.
just know that from the system of unit, the Newton is defined as the force. Okay, listen to the English. It is just the what? The force needed to give a mass of 1 kg, an acceleration of what? 1 meters per second. That implies that your k is equal to what? 1. So I believe you should be able to prove this. Forces, or let's say force, can therefore be defined as the product of mass and acceleration. So now you see where that scenario also came from. All right. All right. So that implies that the greater, that implies that the greater the mass of the body, the greater the force required for a constant acceleration. If I say constant acceleration, that is to that will keep the body moving, okay, or that will keep the body to keep changing velocity, yes, in a constant time interval. So anytime you see constant, it means that what the time is also what constant, exactly. So if it is constant velocity, the time is also going to be constant like that. Okay. Um, and the greater the force, the greater the acceleration for the given um fixed mass. Okay. So the whole of this that they are trying to say, can you explain this scenario to me? What is the whole of this scenario trying to say? You can use a different Any scenario you want to use to explain this to me for me to be able to understand, then we proceed. Hello, could you use your
Like,
own scenario to explain this to me before we proceed?
okay, so when uh when oh, a small boy is pulling a goat through an inclined plane, and the goat has weight more than the young boy, you need to get someone that has more weight than the goat so that you can pull the goat from that inclined plane so that they can move faster.
Oh, you have tried. So that is it. That is as simple as that. You are a criminal. You came to steal my inclined plane. All right, all right, all right, all right. That was a very good example. That was a very good example. Okay. So in this aspect, we are saying that when the body starts from rest, okay. So after reading this relation, we are saying that since the following equation can be written as what? This, okay. Because if you are saying force is equal to what? Force is equal to
Mhm.
mc. Then it means that the acceleration is equal to what? Change in velocity. V minus u all over what? T. Okay. So that is what we have placed over here. And when the body starts from rest, it means that the u is equal to what? 0. So if you put u to be equal to 0, finally, what are you going to get for your formula? Your final formula is going to be
M,
equal to what?
F equals
Force
mv
is
over
equal to
c.
what? Change in what?
Mass change, mass time velocity over time.
So it's just final momentum over time. Final momentum over time. Do you believe final momentum
Yes,
over time? We said it over here. Okay, you see, that is why I
yes.
was showing you that. You see MV. So come and see over here too. So it's equal to what? MV
Mhm.
over T. So force is equal to final momentum over what?
I am
Over
time.
time taken. Final momentum over the time taken. So you should be able to explain to me or a layman to be even able to understand. So note, we are saying that therefore our force is equal to mass times acceleration. Therefore, our force is always the resultant of net force if the body is being acted upon by a number of what? Forces. Okay. So if the body is being acted upon by a number of forces, I taught you vectors. That is, if they are moving in opposite direction, you subtract the force before you use it to what? Work. If they are moving in the same direction, what do we do?